Good evening, friends. This is the operating system, Contiki operating system. So we just spell it like CONTIKI. It's an operating system. So this is one of the operating system which we call it as instant Contiki. So you need not install anything. You can directly download the virtual image file and then make use of using VMware or VirtualBox. So I am using this in my MacBook here. So I am using Oracle VirtualBox. So this is the software I am using. But the image available is for VMware, but you can easily port it to VirtualBox, and it has some tools for Internet of Things. So one simulator is called as the Kuja simulator. Suppose if you don't have any sensors, if you don't have any sensor boards or any IoT hardware, so you can make use of the Kuja and then do whatever you do in real time. You can able to do using a simulator. It's more or less is it's more or less like a emulator rather than a simulator. Also, it has a packet tracer tool called as Wireshark. So these tools are inbuilt. Before going to the simulation, first we will just go and see the Contiki 2.7. So here this is the version Contiki 2.7, but recently Contiki has launched another version called as 3.0. So for this is for the latest use, and there are so many upgradations in Contiki 3.0. So in the Contiki 2.7 we have various folders like applications, the core of the operating system, and the CPU, and the document helpful for, and examples to run for, and the platform it supported, and some tools and some test. So if you see the platform, so these are the platforms supported by this Contiki operating system. So means that these platform, if you have any of these devices with you, so you can able to download the Contiki operating system into the IoT hardware. So for example, there is a thing called as UZ1, there is Volatia sensor modes, and VIS mode is again another sensor modes. And similarly, we have CC2530DK, there's Texas Instrument sensor boards, and AVR Raven boards. So like this, these are all some of these boards. So if you have these kind of boards, you can directly download the Contiki operating system into these boards. This is in the platform. Similarly, the CPU what it supports, it supports ARM AVR. Again, CC2430 Z80 is micro Motorola, and x86 is Intel platform, and PIC microcontrollers 32-bit. Like this, MSP430 is a generic platform for generally for any IoT devices. This is also from Texas Instruments. So this is about this Contiki 2.7 operating system and their source codes. So whenever you do the compilation, all these compilation can be downloaded to the board directly. So you should have a reasonable random access memory as well as reasonable read-only memory to make the operating system to be sitting on the hardware, and you have to run these applications. Okay, so all these operating systems, they never come with a very great documentation, but however they may come with some simpler documentation. But most of the users will be running this operating system using the examples provided by the tool itself. So there are so many examples provided by this tool. So one can explore almost all the tools. So nobody needs beyond these examples for running a perfect IoT application. So today we are going to see a simple web server application which connects via the border router. So there are two different concepts available in this. So maybe I will just write it down. So one we call border router. So this is the router in which it connects to the internet. It connects to the internet, and other we are going to use web servers that tries the border router to connect to the net, connect to the internet. So these are the two things that we are going to do. We are going to use the modes called as sky modes. So it's a type of modes it's available, and we are going to use these modes. So Contiki has a provision of showing how the sky mode looks like, so that whenever somebody wanted to purchase a sensor board or IoT board, they can able to see the diagram and then they can able to make a purchase of it. So with this introduction, we will be moving to the simple application of web application. So first thing is I will go everything with the terminal mode. So first thing is we will open a terminal. So in this terminal, So we have to go inside this folder. So cd Contiki 2.7 cd tools Kuja. So this is the place where we have to run all our simulations. Actually, Kuja is an application which runs using the Eclipse editor. It's look and feel like a Eclipse editor, and it is built upon JDK. So if you want to compile Contiki operating system separately in a separate Linux version, you can able to do that. So if you want to see that, you can able to see using nsnam.com, my website nsnam.com. So you can able to see this. So if you want to compile from the source, you can check the post in nsnam.com about this installation. But as of now, as a beginner user, you can able to concentrate mainly on the instant Contiki rather than the source compiled Contiki. Okay. Now this runs with a tool called as Ant. So Ant is a Java framework that it runs. So this is the command Ant run. So some applications or some users will be recommending the super users, but if you start doing everything the super user, that's okay, well and fine. But here, this instant Contiki has a username and password as user. So the password is user user. So now I'm going to run this application. So when I run and run, so it will compile the Java application. When you run this for the first time, it takes some time to get compiled, but later on it will be faster. And this is our Kuja simulator. So you can see that the Kuja Contiki network simulator. This is the simulator wherein we are going to do the entire simulation. So to begin with, first thing is we create a new simulation. So in this new simulation, Sky Web Server. So I'll use the name of the simulation name as Sky Web Server. And the radio medium, so by default you can leave it as it is. You need not specify any radio medium, but there are so many radio mediums available. So if at all, if you feel you want to work on a new different radio model, then you can try out with the various radio models. So now I am creating the simulation. So this simulation has various windows like network, simulation control, any nodes, mode output, and this timeline symbol. So first what I do is in this network I use the grid as well as I use the radio environment. I'll show you what it makes sense. And in this, the simulation can be performed with the help of running the modes. So first I am going to create a mode. So I am going to create a mode called as sky mode. So this is my sky mode. So the first mode I am going to add. So I am going to process my, so because I am going to add a mode. So what you are going to download inside a mode. Suppose you have a real sensor node, what code you are going to download inside this. So for other that I should know. So I am going to select border router. So IP version 6. So because the entire IoT powers by IP version 6 rather than IP version 4, because the next 5 to 10 years, the total number of devices that is connected to IoT will be around 50 billion. So 50 billion addresses we don't have in IP version 6, sorry, in IP version 4, but in IP version 6 we have sufficient number of addressing devices. So everything powered by IP version 6. So in the IP version 6 we have a RPL border router. So in this RPL border router, you can select border router.c. So again, Contiki runs mainly on C programming. So I'll run border router.c. So once I give this, you can see this code here. Make border router.sky target equal to sky. Since I have selected a sky mode, so the code by default will be this way. So if you if you want to download, if you have a sky mode with you, you can attach it to the USB port, and then you can compile it, and then you can directly upload it to the mode directly, so that the mode will act as a border router. Okay, so now I am going to click compile. So if at all, if you have any doubt, first you can clean, if at all any pre-compiled libraries, you can clean it and then you compile it. So first time compilation will take time, since I have already compiled some time, so it takes faster time. Maybe I will just put the clean, so all the codes will be cleaned. Now when I compile it, so the entire source code will be compiled again. So it takes a little bit of time, so not more than 10 or 20 seconds. Then create. So how many nodes you want to create? So since it's a border router, I want to create only one mode, so you can create modes. So now my border router is created. So once you click this, this is, we call it as a radio. The green color signal indicates that any node lies within the vicinity of this green color symbol, indicates that it has a good radio coverage. So it is the gray colored indicates that not so good coverage, but a little bit of coverage. and beyond this gray color coverage, the radios are not connected to each other, so there will be some packet loss, or the node will not in its radio range, so like that. Okay. So this is what we call it as the radio environment. Okay. So now we need to add the sense. So you can see that what kind of mode type it is. So this is we call the sky mode. So this is the diagram of this sky mode. So if at all when you want to purchase this mode, we can see this diagram and then you can purchase. So now I am going to add some more modes. Again I am going to select sky mode, but this time border router is only once it is connected to the network, so that's why I connected once. Now next thing, I have a web sense. So every node having a web sense that is connected to the towards the border router to connect to the internet. So we have a code sky websense.c. Open it and then you clean it and then you compile it. So what I have done is I have created one border router, and I am going to create, let's say I am going to create 5 uh, WebSense nodes. So whenever you may have a create button is ready, that means that the code is compiled. Don't bother about the warning symbols what you get here. But at times what happens is you will get an error, so that the create button will not be enabled. That means that you have to correct the error and you have to compile it again. So the correction of error might be some packages may be missing, some compilers may be missing, some interpreters may be missing, or some runtime environment will be missing. So you have to correct it perfectly. So if it is in instant contiki, you may not find any problem at all. But if you are going for compiling from the source, you are the owner of everything, you are the master of everything, you are the problem of everything. So you need to solve the problem. Since it is instant contiki, you may not encounter any errors. Now I am creating. So instead of one mode, I create here 5 modes. Yeah. So now the 5 modes by default, since I have given a random positioning, all the nodes are positioned randomly. So what I do now is, for your understanding, so I make node 2, 5 and 4 to be in the vicinity of this node number 1, and 3 and 6 will be in the outside the vicinity of this node number 1. And whenever you want to, you want to differentiate these nodes, so all the mode type, when we select view and mode type, so this indicates that this this mode number 1 is a border router, and all these nodes are belonging to some other type of this mode. Okay. So now my network is ready. Now I need to start my simulation, and this is my start. So when I start the simulation, there will be some package exchanges, or the radio will be detected, and something will be getting transmitted, blah blah, everything will be happening. And if ever I want to provide any nodes, I can provide it, and the timeline will be running here, and this timeline and the mode output will be showing here. So suppose we want to see the net radio messages, so what happens to the radio? So you can click a radio message, and these radio messages, we have a facility called as this can be directly encoded into PCAP, packet 6 low pan analyzer with packet capture. So you can use a packet capture, so that this packet capture can be opened using Wireshark. So Wireshark is a packet analyzer software which is coming freely, and we can able to create the packet capture. Okay, now we are going to run this. So before we run this application, we have to take some more, because whenever we want to connect the nodes, connect the border router, we have a separate command for connecting it. Because what you do is, whenever this border router code is downloaded to a real mode, the real sensor mode, the mode will be powered on, and once it is powered on, it will become acting as a border router. But in simulation, we have to do the same functionality, but there's a separate command for that. Maybe I'll just show you that command. Before I show you that, I want to show the border router serial port. So this is a serial socket server. So more tools, Sky, and the serial socket server. Open the serial socket server, and because I am going to monitor the serial socket of my border router. So it is listening on the port 60001, and as of now the socket mode is 0 bytes and the mode socket is 0 bytes. So I am going to run it now. So before I run this, I was pointing out that there's a command to make the server run. So it is again in the Contiki -2.7 examples IP version 6 RPL border router. So where we taken the border router.c code, you have to go inside this folder, and there's a command called as make connect router -kuja. So actually what happens is, this code make connect router puja. So if you are having a real sensor, what you can do is you can have a make connect router. Means that the router will be connected and the sky mode will be started activating, and it act as a border router. But since we are going for a simulation, we use the connect router puja. So here for that the password is user, because this needs administrative privileges, and we use this. And yes, and now this is the TunSlip. It is one kind of protocol which is used to capture the routing packets, and it will tell you what is the IP address and everything. It will tell you, but still the server is waiting. So I will just go on run this server now. So now I started my simulation. Now once I start this, you can see that the number of bytes it occupies, it will be showing here, and the radio messages are popping out here, and this is how the timeline axis is going on, and here this is the mode output, and here the simulation is running. So for a better limit, you can make this speed limit to be 100, so that it is in exact user viewing experience of 100% of speed limit, and then we can able to see that. So now we can see this, the server IP addresses are being shown this way. So a colon 212 colon 74001 colon 1101. Okay, now what I do is I'll just copy this. Because I want to check whether the web server is working or not. And then what I do is I will just open my browser. So in my browser, what I do is, so I use HTTP protocol, HTTP colon / I use control V. So I use AAA. So this is the location of the server. So it is something like we do in IP version 4, 127.0.0.1, and press enter. So it will be acting as a localhost. Similarly here, the server IP address is in the in the IP version 6 format. So it should be enclosed within a square bracket. And as it is same with HTTP. Now when I press enter, it shows 505, 404 and 202 are in range. They are the neighbors, and it compute the route also. So I will just come to my simulator here. So view here, addresses, IP address or RIME address. So when we see IP addresses, you can see this 101 is the border router, 404, 505 and 202. Now we can see 404, 505 and 202. So they are the neighbors, because it is in the range of the green color circle is in this range. But the routes also you can see 505 going via 505 and 606 go via 505. So this is 606, it's go via 505. So means that 101, 505 and 606. And similarly 303 and 505. And you can see 303. So 303 goes via 505. Yes, 303 is here, is going via 505. And this is how it computes the route. Suppose if you want to compute what is happening in this node number 2, for example, so then I will just change my node number 2. So what I do is I will change my node number 2. So when I select node number 2, so because node number 2 I have taken the WebSense nodes, so it has some readings. The reading is the light is 302, it's a lumens, and the temperature is 24 degrees centigrade. At that particular node, the temperature maintained is 24 degrees centigrade. So this I can able to read it. So what I am doing now is, now I am reading from these sensors. Within my simulator, I am reading this data. But when you fuse these codes inside your mode, and these modes are placed elsewhere, these modes will compute the temperature and the light as per the readings what is given. So now see that the node number 3 senses 157 and 24 degrees centigrade. Of course, node number 3 is not the neighbor, but it is the route computed via that. So still the border router or the node is fetching this value. And I will check with number 5. Node number 5. So this node number 5, it indicates so 114 and 24 degrees centigrade. So each and every of these 5 nodes will be recording their current readings accordingly to this simulator. So this is a perfect example of a web server which is routed via the border router. So we call it as a border router, or in simple networking term we can call it as a gateway. So the gateway connect to the internet. And this file is, suppose if this radio value is what happens to the payload, everything, how the radio is getting affected, or how the radio is consuming power, all these things you can save this into a file. So you can save this of any file. So let's say I use hello, so you can save this as a text file, hello. So whenever you want to debug this file, you can able to debug it. So you can able to debug using this simulator. Hello. So you can able to see what happened to this each and every node. So you can able to see the IP version addresses. So this 212.7402 is at node number 2. So like this you can able to check the what happens with the radio model. So it records everything. So this way we can able to do a simple simulation. And this is a simple simulation done in a Contiki simulator. It's a Puja simulator, but this can be extended to a real mode also if you have a mode with this with you, and these codes can be downloaded to the mode directly. Okay, thanks for your time listening to this video. So for any more lectures, you can always refer the nsram.com or my YouTube channel, youtube.com/tspradeepkumar. This is my YouTube channel, so I am just showcasing my materials on NS2, NS3, and now IoT. So these three topics related to this three topic simulation and related to networking, everything will be showcased in my websites nsram.com and youtube.com/tspradeepkumar. Thank you for your time.